And I want to start kind of talking about some things that I observed in your guys' most recent homeworks that you did. So I saw things like, like a problem like this. And I saw some of us answering this as like not factorable. And that's not really an appropriate response to this kind of a question. Notice that it has equals 0 at the end, and the directions we're going to be to solve this. Every quadratic is solvable. Doesn't matter if it's factorable or not. That's immaterial to your ability to solve the problem. So regardless of what's going, what the problem looks like or whether you can factor it or not, all of these quadratics are solvable. You should always try to solve it. Saying no solution or not factorable or not solvable or any of these things is not an option. We've done enough to where you can do you should be able to do every one of these quadratic problems. So kind of stay away from that. On a similar note, I saw people responding to this as like, these kind of problems as like, no solution or something. Again, all these quadratics are solvable. Sometimes they're going to involve complex numbers. Sometimes you might have to use something other than the quadratic formula or factoring to solve them, but that's okay. We've talked about all of these different methods, and they're all solvable. So they're all solvable. And on that note, before we go and jump into questions or whatever, I just want to do like a little overview on solving. Again, looking at the last homework assignment, it felt like this would be a good place to kind of, as a jumping off point. So if we have a standard form polynomial, to solve this, it has to equal 0. So the first thing we really must do is you have to get everything onto one side. So you might have to add or subtract things to both sides of the equation, but the first thing is it must be equal to 0. So one way to solve it is you could factor. But we know that factoring is not always possible, right? Using our factoring methods, there have been things that we can't factor. That's okay, because we have other tools that we can use. So you could also use the quadratic formula. The quadratic formula always works. And in some cases, you could write this as a vertex form problem and use the reverse order of operations. So these situations are kind of rare, but they'd be ones where like this 2x squared plus 5 equals 0, where you don't have x's, you just have x squareds. So this would be an option there. Okay. The other option, or another situation, this form. So to solve a vertex form problem, we're going to use the reverse order of operations. Note here that it doesn't have to equal 0, right? So if there's like a 5 equals 5 or 10 or 17 or whatever, that's fine. The other option is you could write it as a standard form, you know, where you have to like expand it out and combine like terms and all that jazz. And then once it's in standard form, you could use one of the standard form methods like factoring or the quadratic formula. But in general, you probably don't want to do that, as it's a bit more work to get there. The reverse order of operations is actually pretty quick, and probably preferable to rewriting it as a standard form. Just end up probably having to use the quadratic formula afterwards. So the last situation is if we have something that is in intercept form. And if it's equal to 0, no problem. We just use the zero product property to solve each piece. Or, I mean, you could FOIL things out to get a standard form and use a standard form method, but like, I don't know why you'd want to do that, as it's much easier to just set the individual factors equal to 0 and solve them. Now, if you have an intercept form that's not equal to 0, then we're in a different situation. So there's no way to like make it equal to 0 and stay in intercept form. So what you're stuck doing is you'd have to write this as a standard form. So you'd have to FOIL it out and then use a standard form method. So that's a quick little overview of like when to use which solving method. Looking at the homework, it seems like oh, you can't see what I'm writing on the screen. This is a thing where like unmuting yourselves and like telling me that would have been totally cool. So if again, like if I'm doing something stupid and it's clear that like, oh, I couldn't hear a thing. Is my volume all the way down? No, my volume's all the way up. Now that's
like the last hour.
That's the first time I could hear any of you saying anything.
We also typed it in the chat.
Yeah, no, I saw that eventually. I'm quite embarrassed. My apologies, guys.
Okay, I forgive you, Mr. Kulik.
Yeah, that's you know. All right. So okay. So what do we need to do here to get back on track? You can see the screen now, I take it. Yes?
Yes.
Okay. So I started by saying that like on some of your homework I was noticing some people were saying like that this thing is not factorable, which is true, but I don't care because it would have been a solving problem because it was equal to 0 and it's still solvable. So like not factorable doesn't matter to me. And some people were saying things like this had no solution. And I was saying that all quadratics have a solution for us now. We've done enough to where all of them are solvable. So you shouldn't be writing that for any of your answers either. And then I did this overview on solving about like when to use what methods. So if you have an equation that's in standard form, it has to equal 0. So the first thing you need to do is like add or subtract things to both sides to make it equal to 0. And then to solve it, you could factor, although that's not always possible, but when it is, it's usually pretty quick. You could use the quadratic formula. This always works, which is lovely. Or in some cases, you might want to think about it as a vertex form problem, so you could use the reverse order of operations. But I would limit that to stuff where there's only x squareds and no x's. You know, like 2x squared plus 5 is one where you could use the reverse order of operations, and it's probably going to be faster and easier than like even using the quadratic formula. If you have a vertex form problem, you can use the reverse order of operations, and it doesn't matter if it equals 0 or 5 or 20 or 100. That part doesn't matter. You can still use the reverse order of operations. Or you could like multiply everything out so that you have a, you know, do your foiling and all that, so you have a standard form equation, then use one of the standard form methods above. I don't know why you would want to do that. But you could. I don't know that it would be a good idea, but it's possible. It's not wrong. And then if you have an intercept form problem, if it's equal to 0, you can just use that zero product property to set each factor equal to 0 and solve them independently. That's massively easy. As opposed to the other way, you could multiply it all, do all that foiling out so you get a standard form equation, and then use one of the standard form methods above, but like, don't do that. Now, if you have an intercept form problem that's not equal to 0, you're stuck in that you have to FOIL everything out to get it into standard form and then use one of your standard form methods. So this is just a little overview of like what method to do depending on kind of what your problem looks like. And it felt like looking at the homework that this might be a good place to start. So sorry about the screen share thing. But again, all this stuff is in the notes, and I'm recording what's on my screen. So if you went back and watched the video, you'd be able to see it still. I know that doesn't help you right now. Okay. So homework 9 was what you guys had to do for the last homework check. I'd like to take any questions from homework 9 if you have any. So if you do, you could type in like number 7 or whatever into the chat if there was something you wanted to ask about. And if you don't, that's fine. No big deal. But if you did, now's an opportunity to do that. Wouldn't necessarily be your only opportunity. We could certainly come back and revisit this later if you needed to. But I'll just pause here for another minute or two to see if anybody wants to take the bait on that. And if you don't, no big deal. Number 9, certainly. Okay, so number 9 is in standard form. I noticed the leading coefficient is 1, so if it's factorable, it would be one that I could use a shortcut on, and this problem would be very easy. Potentially very easy. So I'm looking for two things that multiply to give me 29 and add to give me negative 10. Well, that just doesn't work, right? There's not two whole numbers that do that. So rather than trying to factor, which is now not possible using our methods, I'm going to use the quadratic formula. So x equals negative b plus or minus square root b squared e all over 2 times a. So I'm going to go ahead and just type the part underneath the square root symbol into my calculator. Remember, the name for that part was called the discriminant. So when I do that, I get negative 16. And remember, when we square root a negative, to get rid of the negative under the square root, we use an I. And then we can just take the square root of 16, which is 4. And now I could write 2 fractions. So 10 divided by 2 is 5. 4i divided by 2 is 2i. So my answer would be 5 plus or minus 2i. Is that okay, Ava? Okay. Again, if I address you directly, you could always unmute and respond to me, or you can respond in the chat. Either is fine. Okay. So today we're going to talking about a new topic. I'm going to talk about graphing today. Just as an aside, we've covered solving and simplifying so far. We still need to talk about graphing and modeling inside of this chapter. Now, graphing and modeling are considerably briefer topics when it comes to a quadratic as compared to simplifying and solving. So this will be much quicker, these last 2 topics, just to give everybody a heads up as to kind of where we're at in this side of this chapter. It's been a long one, and that's okay. All right, so talking about graphing. So the graph of a quadratic is called a parabola. And a parabola kind of looks like a U. So that parabola could open upward, or it could open downward. And it's easy to tell by looking at the equation of your quadratic whether your parabola is going to open up or open down, because it's just based on whether the a coefficient is positive or negative. So a positive a value, the parabola will open up, and a negative a value, the parabola will open down. And when I say a value in one of the 3 forms for a quadratic, Intercept form, Vertex form, or standard form. So we're just talking about those A's. So the next thing we'll talk about are the key features of a parabola. So let's say we have a parabola like this. This point that I've labeled as A is what we call the vertex. And the vertex is just the highest or lowest point on a parabola. If the parabola is opening up like this one, the vertex is the lowest point. If the parabola was opening down, the vertex would be the highest point. all parabolas have symmetry. So their line of symmetry is called the axis of symmetry. That's what I've labeled as B. So the axis of symmetry is going to be a vertical line that divides the parabola into two mirror images. Or mirror halves, I should say. Parabolas can have X-intercepts, but not always. So the X-intercept is just the place where the graph crosses the x-axis. So a time where a graph might not have X-intercepts is if your vertex is above the x-axis and your graph opens up. Right? If you're above the x-axis and it goes up, there's no opportunity for it to ever cross the x-axis, right? And the last value, or the last key feature, is the y-intercept. And that's just where the graph crosses the y-axis, and a parabola always has a y-intercept. Not always x-intercepts, but always has a y-intercept.
Mr. Bullock?
Yes.
Can you just scroll up a little bit?
Was that enough?
Yeah, thank you.
You're welcome. So, at this point, I don't need you to ever be able to define what these terms mean. It's just one of those, should you be able to recognize them on sight? Like if you see the graph of a parabola, be able to pick out where these different points are. That would be as much as you'd really need to be able to do. So there's no need to give a formal definition that you need to memorize. It's just one of these sight things. And some of these terms like X and Y intercepts, I expect that you're kind of already familiar with. And the vertex, again, is very similar to what we dealt with absolute values. So again, not an unfamiliar topic or unfamiliar idea. So let's talk about how we find these things. So finding these key features algebraically. So I'm going to actually start at the bottom of the list and work up it. So for the y-intercept, we're just going to plug 0 in for x and simplify. So for example, if we have the standard form polynomial, y equals, or standard form quadratic, 2x squared plus 6x minus 3. If I plug 0 in for x, 0 squared is 0, 2 times 0 is 0, 0 times 6 is 0, 0 plus 0 is 0, and 0 minus 3 is just negative 3. So our x-coordinate is negative 3. So that would be my x-intercept. Not too bad. What if we had something that looked like this? Well, you should recognize this as vertex form. And then we'll do the same thing. We'll just put 0 in for x. 0 plus 1 is 1. 1 squared is 1. Negative 2 minus 3 is negative 5. So my answer here would be 0. And on our last example, so 0 plus 1 is 1. 0 minus 3 is -3. 3 times 1 times -3 is -9. So 0, -9 is my y-intercept. Any questions about finding y-intercepts? Okay. Next up is X-intercepts. To do this, we're going to plug 0 in for y, and then solve for x. So let's say our quadratic is y equals x squared plus 8x plus 12. And I observe that this is standard form. So if I plug 0 in for x and then solve, I have a standard form quadratic that's equal to 0. To solve this, I can either use factoring or use the quadratic formula. Since the leading coefficient is 1, if it's factorable, it's going to be really fast to do that. So I'm going to try to factor it. Two numbers that multiply to give me 12 and add to give me 8 are 6 and 2. So it is factorable. So I can then solve this by setting each of these factors equal to 0. When I subtract 6 from both sides, I get -6. And when I subtract 2 from both sides, I get -2. So my x-intercepts are -6, 0, and -2, 0. Again, because I got x's, I know that those numbers are the x coordinates. Because I plugged 0 in for y, I know 0 is the y coordinate. Next up, let's say we have y equals 1/2 times x plus 3 quantity squared minus 8. I notice that this is a vertex form equation. And so if I go ahead and I plug 0 in for y, I can solve this by using the reverse order of operations. So I'm going to add 8 to both sides to undo any addition or subtraction. And then I'll multiply both sides by 2 to undo the multiplication there. And then we got to square root both sides to get rid of that exponent. When I square root both sides, that creates a plus or minus. And then we got to subtract the 3 over. And I can treat this as two separate. One is an addition problem, and one is a subtraction problem. X and -7 is equal to x. So my x-intercepts are 1, 0 and -7, 0. And then the last and easiest situation would be something like this. Y equals -3 times x plus 3 times x minus 5. You should recognize this as an intercept form problem. So we'll plug 0 in for y as we do for all of these. And then I have an intercept form equation that's equal to 0. I can solve this by just applying the zero product property and setting each of them each independently. Well, 0 equals -3 is a bunch of nonsense, so that part gives me no solution. To solve 0 equals x plus 3, I can just subtract 3 from both sides. And then to solve 0 equals x minus 5, I can add 5 to both sides. Oops, I didn't mean to box those. So no solution doesn't do anything, but -3 gives me the point -3, 0. And x equals 5 gives me the point 5, 0. So those are my two x-intercepts. Any questions about these x-intercepts? Okay. Next up is, so B is the axis of symmetry. So somebody is unmuted that's like rifling around through pages, which is totally fine to be looking through things. But if you can remute yourself, that would be good. Thank you. So the axis of symmetry we're just going to find with a formula. So that formula A for vertex form, that formula is x equals h. And for intercept form, that formula is x equals p plus q over 2. So these are three important formulas. You'll need to use these on the homework, so make sure that you highlight them in your notes in a way that it'll be easy to go back and find them. I'm going to put a big red box around mine. So let's do some examples. So here we have a standard form equation. So to find its axis of symmetry, I'm going to do negative b over 2a. In our case, the b is -8 and the a is 2. So negative of -8 is +8, and 2 times 2 is 4, and 8 divided by 4 is 2. So my axis of symmetry is x equals 2. Note that this is the equation of a vertical line, not like a value when we're talking about an axis of symmetry. So just to want to point that out. I know it looks just the same way, but context matters. The fact that we're talking about axis of symmetry tells you that we're talking about a line, so this is a vertical line because it's an x equals. So the next one, you should recognize this as a vertex form equation. And for vertex form equation, we just have x equals h. And I know h is just the opposite of whatever that is. So x equals 6. That's it. Pretty easy for those. This next one we should recognize as intercept form. So the intercept form is p plus q over 2. So I know p is the opposite of that first value, and q is the opposite of that value. So we have 3 plus negative 5 over 2, or just negative 2 over 2, or negative 1. So these axis of symmetry problems shouldn't be too bad. Basically, you're just making sure you're using the right equation and plugging in the right values, but it's just using an equation. Does anybody have any questions about axis of symmetry? Okay, very good. The last key feature we need to talk about is the vertex. So the vertex is a coordinate. The x-coordinate is the axis of symmetry. So the same x value there. And the y-coordinate we get by plugging the axis of symmetry in for x, and then simplifying. So the first step in finding the vertex is to figure out the axis of symmetry, because that's just going to also give us the x-coordinate for the vertex. So rather than coming up with 3 brand new problems and then finding the axis of symmetry all over again, I'm just going to go back and use the previous 3 problems from that last example for axis of symmetry and just continue the work there in blue. So is everybody okay with that? Okay, I'll take from your silence that there's no objections then. So I'm going to write Vx for the x-coordinate for the vertex. That's just going to be 2. And Vy is going to be the y-coordinate. I'm going to just get that by plugging 2 into my function. So 2 squared is 4. 4 times 2 is 8. 8 times 2 is 16. 8 minus 16 is negative 8. And then plus 3 is negative 5. So my vertex then is the point 2, negative 5. For the next one, my x-coordinate for my vertex is 6. And the y-coordinate is going to get, or I'm going to get by plugging 6 in for x. 6 minus 6 is 0. 0 squared is 0. 0 times negative 3 is 0. And 0 plus 4 is 4. So that's going to give me the vertex is 6, 4. It's worth noting here, in vertex form, the vertex is always just h comma k. Notice that this k was the same as that k. That's why we call it vertex form, is because we can just get the vertex basically by sight. By just identifying the h and k, we don't really have to do any of that stuff that we did before. You can still do it, it doesn't make it wrong. It's just a little bit of a time saver, specific to vertex form problems, though. And then our last example, our x-coordinate for our vertex is negative 1. Our y-coordinate then, we're just going to plug in negative. So -1 minus 3 is -4. -1 plus 5 is +4. 2 times -4 times +4 is -32. So my vertex is -1, comma, -32. Any question about finding the vertex? No. Okay. That's very good. And really, finding these key features is the most difficult part of graphing. Actually, creating the graphs is not that difficult. Let's see. We'll say draw. So to draw the graph for a quadratic, we need the vertex and then 2 points on either side of the vertex. And that's it. After that, we should have everything we need to draw our graph. So let's do a quick example. Let's say we want to graph 2x squared plus 12x minus 5. Well, the first thing we need to do is find the vertex. So to find the x-coordinate is finding the axis of symmetry. So I'm going to use, since we're in standard form, negative b over 2a. So negative 12 over 2 times 2, which is negative 3. To find the y-coordinate for the vertex, I'm going to plug negative 3 in for x. So is 9, and then 9 times 2 is 18. 12 times negative 3 is negative 36. 18 minus 36 is negative 18. And then negative 18 minus 5 is negative 23. So there's my vertex. So now all I need to do is find my 2 points on either side of the vertex. So to do that, I'm just going to make myself a little XY table where the vertex is the middle point in that XY table. And because I'm putting the vertex in the middle, it's usually easier for me personally to write my table horizontally as opposed to vertically. But whatever floats your boat is fine. Now, to make sure that my points that I'm about to choose are on either side of the vertex, I need to pick 2 points whose x-coordinates are less than the x-coordinate for the vertex. So I need 2 numbers less than negative 3. Any 2 numbers will do, but don't make your life hard. Pick easy whole numbers. And then I just need 2x, and I get the 2 points on the other side of the vertex. I need 2 x values that are bigger than the x-coordinate for the vertex. Again, don't make your life difficult, just pick easy whole numbers to use. Ideally, you'd like them right in a row like that. So now all we need to do is to find their corresponding y-coordinates. And the way we do that is just by plugging them in to the function that we were given. So negative 5 squared is 25. 25 times 2 is 50. 12 times negative 5 is negative. And 50 minus 60 is negative 10. Minus 5 is negative 15. Negative 4 squared is 16. 2 times 16 is 32. 12 times negative 4 is negative 38, or negative 48. 32 minus 48 is negative 16. Minus 5 is negative 21. And just continuing on. So that also gives 1. Oops. That meant to be a 1. And that also gives me negative 15. So at this point, if you look at our table, you might have noticed there's like kind of a pattern going on, right? Where some of these y coordinates are repeating. And you might ask yourself, well, does that always happen? And the answer to that is it can always happen depending on how you're choosing those other 4x or those other 4 points. So notice here that the distance between negative 4 and negative 3 and negative 3 and negative 2 is the same. They're both 1 unit apart. If that's true, then their y-coordinates will be the same. So the distance between a point and the vertex on the horizontal, again, if that's the same, like negative 3 apart and negative 5 and negative 3 are 2 units apart, so their y-coordinate should also be the same. So you can pick your x-coordinates so that they are going to line up so they're symmetric like that, and you can get the y values to repeat. And it's going to happen naturally almost all the time, as long as you're picking like sensible x values. But again, you have the freedom to pick whatever x values you want. So depending on what x's you pick, that may not happen, right? If I had, instead of picking negative 2 and negative 1, if I had picked 0 and 1, the y-coordinates would not have matched up the same way. Is there ever a situation where it would be more convenient not, or to pick my x value so things didn't match up? Sure. Say, for example, your x, or the x coordinate of your vertex was like 2/3. To get it to match up, you'd end up having to pick fractions for all of your other x coordinates, which just like kind of is a bigger pain in the butt than just picking whole numbers and having to plug 4 of them in. But in general, that you'll see that happens more often than not. Okay, the last thing I need in range, and this is pretty easy. Oh, we didn't draw a graph. Ha! Let's do that first. So we found all these points, right? So let's see, -1, -2, -3, -4, -5. These are going awful big. I think I'm going to go by 2s. So -2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2. Okay. So -5 and -15. It's like there-ish. Right, 2, 4, 6, 8, 10, 12, 14, 16. Yeah, so it's like in between. And then -21. So like there-ish. And then -3 and -23 is like there. So So when I draw my graph, it looks like... Almost forgot to draw the graph after we did all that work. Ay caramba. Okay. Returning to my original thought here, which was domains and ranges. The domain is easy. It's always the same thing for all quadratics. It's negative infinity to positive infinity. We love it when that happens, when something is always one way. It's like super easy to remember. The range is a little bit different, but not too bad. That depend on the value of a, whether the parabola opens up or opens down. So if the a value is positive and the parabola opens up, we're going to go from the y-coordinate of the vertex to positive infinity. Note that the y-coordinate of the vertex has a bracket, not a parenthesis. And if the a value is negative and the parabola opens down, we're going to start at negative infinity and go to the y-coordinate of the vertex. Again, notice that that had a bracket and not a parenthesis. So if I go to my previous problem here, the domain, well, I don't really have to do a whole lot of thinking about that. You know, just negative infinity to positive infinity. The range, well, if I go back, I look here, the a value is positive, the parabola opens up. I could tell that by looking at my graph even. So I know we're going to go from the y-coordinate of the vertex, which is negative 23, up to positive infinity. And that's it. This is where we're going to stop here today.